Alright, and here we are again. Now is with Node. So, since yesterday, I went through how to build a GraphQL. What is a GraphQL server? What are the benefits of using GraphQL over RESTful API architecture design? And what are the main issues that GraphQL solves, like underfetching, overfetching? It provides schemas and types and speed up the development. However, the trade-off is, since this flexibility, it comes with a price, it adds complexity. And also it's very difficult to catch, even though that there are already methods where you can find them on their docs. But unlike RESTful architecture, where you already have proven catching methods that you can go with them, and it's not RESTful, meaning that most developers are familiar with this architectural design API, which has decades on the industry. And now we have this new way of building APIs, and how do we interact with them? So I also look at the specification, who made this tool, Facebook in 2012. Also, the frameworks like React that allow you to interact with GraphQL servers. And getting started to look at the graphical or this built-in browser front-end tool to test GraphQL queries. See the benefit of using this tool that we can is query nested objects and see the real benefit of doing that. It's like it is trivial and very easy to query really complex data structure and get the data that you want. So I also look at tools like Apollo that allow you to build front-end and back-end GraphQL server. And before diving into that, we need, or I look at how can we create a GraphQL server from the scratch to know how to do that. And then I started to look, or I use Express for building is this GraphQL server using an Express middleware for that. Define is a type system, something that I'm going to show you here right now. Define a type system. Define a type system. What is this? Here. Define a type system, or the schemas, which is after all is a string, and see that you in all GraphQL server you have a entry point or a type called query, which is the entry point, and see also how you can test your GraphQL endpoints using tools like Postman or Insomnia, where by making a HTTP post request to the server and then sending us the data, we get the data that we want. So then I look at things for more realistic scenarios, such as building a e-commerce schema. And since deep nested objects are very common in e-commerce applications or any apps that has some technical depth, so as I mentioned before, it is very easy to query really complex data structures and get the data that you want. So our API now is organized in types and fields rather than endpoints. So making additional extra requests to compose multiple collections of data to show them to the user now is irrelevant. So we save bandwidth and time for that. Part of the issue that GraphQL solves, like underfetching and overfetching. And then I look at GraphQL tools because if you want to create large scale GraphQL projects, we can rely on tools like define a more modularized schema, okay, by breaking down your GraphQL service into multiple files or multiple types, and also help you to organize your server by functionalities. And if you need to add complex logic to affect your data, make it manageable and scalable as well. So first I look at how can we do that using schemas, all right? And by relying on GraphQL tools like makes executable function and load files, where you in there define is the type of files you want to look up for your in your project folder structure. When it comes to a schema, we define it using the .graphql uh, and inside that file, for example here, and inside that file, we define is our schema for that collection or for that type of data. Uh, and this is for a schema. And another capability or another component that GraphQL has is resolvers. And to answer that question, it all starts with asking or to understand how query works. So when we make a query, GraphQL determines if the query if the query or GraphQL query is valid by look at the type system or the definition here, and then execute that query. And while executing that query, the properties here, so the properties, or to determine the value of those properties, there is a function called resolver that does that. So when you define here your graph, when you define, let me look here at the local host. I'm already running this service. So what you define here is fields, all right? It will execute a proper resolver. So when the server has run all of the proper resolvers, it will wrap that up and then send it back to the front end. And the reason of using resolvers is that it allows us to make inside of this function, resolvers, API calls or any async operation as well. So a great example of that is that when we look at our resolvers here, so for example, here we can define this as a, let's say, we want is to make this the product an async resolver or async function, where here we say, hey, I would like you to using a promise when you get that, when you get that result, you get that value. Okay, once you solve this promise, you're gonna wait for this, and let's going to assign that to a variable called product, right? Oh my god. Okay, and then you're gonna return is product. Okay, now let me rerun our server here. Okay, and the beauty of this is that when we make a query for the product here, we get that uh, as our response. So that's one of the great things of using resolvers. So how can we organize our resolvers in a much modularized way? Okay, it's much like as the way we did with our schemas, but in our case here is we define a file called the name of the type dot the resolver.js. Okay, in our case the product resolver.js or the orders resolver.js. And since we want to make a distinction between the data access layer, the resolvers, and how the server, this is now the architectural design. The front end will make a request to the server, and now the server will make a request to any uh, storage that have our application or that hosts our application or any place where our application store persistently the state of our app, and that is a database, whether it's a relational database, key value, graph, white column, or document based. So we rely on that. So in our case, here, by creating is a model here, and right now we are hard coded our data, so we store that in memory in our server, and defining is this data layer access or this data access function. Okay, where when we want to make these async operations, we can wrap them inside of this function. So for the sake of example, here what we did is just doing that in memory. Okay, uh, so now since we are here modularizing large GraphQL projects, the resolvers. Okay, now we want to make a more realistic scenario. We want to make a more a more realistic or real life project rather than fetching data in memory. So that is the next topic. Okay, and there we are. The database, no production close, GraphQL, and here we are. Okay, exactly. So yeah, so we are already modularized large GraphQL projects in the resolvers here.
We no longer need this root object, so we can remove that, and we no longer need to pass in these default values.
Oh, I didn't get status here. That's right. Git add. Let me add all of this. files, git commit minus m resolvers, or we can write is add resolvers, uh, add resolvers models, add resolvers models, right? You say git push origin to the main branch, because now it's racist to say master. Yeah, part of the linguistic revision. And okay,
into GraphQL. Instead, the data all comes through our executable schema from each of our resolver functions that talk directly to our models. This is a much more realistic, real-life GraphQL project structure. This is also how I would structure my own GraphQL projects. All right, our resolvers right now are...
So let me put it here. That's right. Now this is a more realistic project structure of our so now this is a more realistic project structure of a GraphQL server. And here what I can do is, by getting here on GitHub and take a look at what is my repo here, especially this repo, right? The Express GraphQL test. So here what I can do is to add this commit, that copy. I don't know what are you copy. Okay. So yeah, this is the commit for that, and let me paste this here. No, wait, it's not. It's not here. It's right below here, along with an image. This image here. Okay. Okay. Now next.
super simple. In the next video, let's explore some practical use cases for resolver functions, where we pass in arguments and use those arguments to filter the data that comes back in our queries. It's going to be a good one, so I'll see you there.
More practical use case. Okay. That is the modularizing large GraphQL project. Modularizing large GraphQL project. Do resolvers. I mean, filtering with query and result. Oh, sorry. Filtering with. I can barely see what am I writing here. Filtering with queries and resolvers. Yeah, with queries and resolvers. Exactly. So here we're going to see a more realistic, or a more no a more realistic, a more pragmatic.
For some practical use cases,
Exactly. So here we're going to see more practical use cases.
for resolver functions, where we pass in the next video, let's explore some practical use cases for resolver functions.
Practical use cases for resolvers function. So I'm
where we
assuming
pass in arguments
okay, when we pass some argument,
and use those arguments to filter the data that comes back.
okay, well, exactly, and use those arguments to filter out data that comes back from the database.
Back in our queries. We pass in arguments and use those arguments to filter the data that comes back in our query.
Okay, filter out the data that comes back in our query. Okay, meaning that the client sends some arguments to filter out the data. So, for example, hey, I just wanted to look at the latest 10 items in my catalog or in a product catalog based on electronics. Okay.
It's going to be a good one, so I'll see you there. By ID, and I'll see you in the next video.
What? For real? Okay.
Right now, our queries and the corresponding resolvers have been quite basic. We just return back all the data in our list of products, or all the data in our list of orders. What if, instead, we wanted to get a single product by its ID? Or if we wanted to filter our products to get back those that are in some price range? These are super common use cases. On Amazon.com, our products to yours. What if, instead, we wanted to get a single product by its ID?
Okay. What if we want to get a single product by its ID? That's a common use case.
Or if we wanted to filter our products to get back those that are in some price range.
Or filter out products by some price range.
These are super common use cases. On Amazon.com, a product.
Yeah. These are very super common use cases.
Product details page would get the details for some individual product based on its ID. There's no need to query the entire list of products when loading that product details page on the front end. And when searching for products, our users will very likely be interested in filtering what products are shown to them based on different criteria, with price being a very important one. All right, so let's support both of these cases in our own GraphQL server. So what products are shown to them based on different criteria, with price being a very important one. All right, so let's support both of these cases in our own GraphQL server. So what is the GraphQL approach? We're going to be using parameterized queries, or...
Okay. The GraphQL approach is to use parameterized queries. The GraphQL approach is to use, without the, parameterized queries.
Queries which accept arguments. Just like when we list all of our products, we're going to be adding a new query at the top level of our schema. This time, instead of listing all products, we're going to name our query to filter products by price product this time. Instead of listing all products, we're going to name our query to filter products by price. This is going to accept two arguments, which we...
Again, this is... Okay. This is the GraphQL query of doing this. The GraphQL approach by defining it's a type.
Include in our schema in these parentheses, and these are going to be the...
And here you're describing is the capability of this GraphQL server.
Minimum price, which is going to be compared against a price. So it needs to be a float, which we'll add after the name of the argument. We're also going to have a maximum price for the upper limit, which is also a float. Now, just like before, this query will return a list of products, with product as the type, surrounded by these square brackets. To keep things simple and not worry about undefined values, we're going to say that both the minimum price as well as the maximum price are required values with this exclamation mark after the type. Now, to implement this query, we need to add a corresponding resolver.
So this is the GraphQL approach,
which we include in our schema in humans. So let's support both of these cases in our own GraphQL server. So what is the GraphQL approach? We're going to be using parameterized queries, or queries which accept arguments. Just like when we list all of our products, we're going to be adding a new query at the top level of our schema. This time, instead of listing all products, we're going to
add a new query here. So we are going to add a new query for this. A new query for this.
Name our query to filter products by price. This is going to accept two arguments bounded by these square brackets. To keep things...
Okay, so because here we want us to add a new capability on our server to get a more realistic or a more practical use case of resolver, we here are going to define a query called product by range by price here, and by defining this as parameterized queries, again, this is a more practical use case of using resolvers. So here we want us to get is a list of products by price, and here you're going to pass is the mean as float and max as float. And to keep simple and to keep things simple, we're going to indicate that this argument must be required, and here you're going to return is a list of products, or product in simple, right?
Simple and not worry about undefined values.
Exactly. So no worry about undefined values here.
We're going to say that both the minimum price as well as the maximum price are required values with this exclamation mark after the type. Now, to implement this query, we need to add a corresponding...
Exactly. Now, to implement this query,
resolver,
we need to add the resolver.
It's going to live in our products resolvers because it has to do with our product model. So we'll add it as a query underneath products, with a property that matches the query name. So products by price. Now, unlike for the getAllProducts resolver, this resolver will make use of one of the arguments that GraphQL passes each resolver. So this is going to be an anonymous function. And remember that the possible data that we can get includes the parent, which might include any root default values if we had them, and also this args argument that contains any data passed into this query. It's this args argument that's going to be key to creating these filtered queries. To get a better picture of what this looks like, let's take a look into our graphical interface. Say instead of querying all the products for their description, we only wanted to get the description of the products that cost between $10 and $50. If we know there's a query that allows us to get products by price, we could add that as the name of our query. Any arguments to this query would go in parentheses immediately afterwards. We know that we're querying by price, and we're going to need a minimum, which is $10, and a maximum, which will be $50. Right now, we haven't completed the query, so GraphQL is telling us that there's no matching query with that name. But this is what we're trying to build. We now have a pretty good picture what we're aiming for. So let's see how we might support this in the server. We pass in the minimum and maximum price as arguments that are going to come back as args.min, that's the name of the parameter when we made our query in GraphQL, and args.max are going to come back as args.min, that's the name of...
Okay, so now to implement this query, we need to add the resolver. And to do that, by using is the product price, and as we remember,
the parameter when we made some function in our products model. The implementation of this model function will depend on going to be values that we pass in as arguments to some function in our products model.
So now we need some function to pass here.
We're going to have a new function. We'll pass in as arguments to some function and args.max. These are going to be values that we pass in as arguments to some function in our products model. We're going to have a new...
Exactly. So we need some function to pass into our... Yeah, so now we need some function to pass into our product, but into our function.
New function below,
or into our product model, into our product.model.js, right?
getAllProducts. That will instead be function getProductsByPrice.
And here is where we're going to the... Okay, so now that we define here the query and their corresponding resolver with product, which is here by saying, hey, you know what, products by price. Okay, where you're going to get is this parent. We need is to define this if we want to get the root value from that, and the arguments, okay, we will contain is the parameterize for make our query, to make our query. And here we need this function like min and our max to pass to our models, product models. So product models here we're going to define is a function called get product by price. Okay,
which filters the products between the minimum price and the maximum.
Exactly. Which filters the product for with minimum price and maximum price.
The implementation of this model function will depend on what our data model is.
Mm-hmm. What we have is this. The implementation of this function will be based on which data or
whether it's this in maximum. The implementation of this model function will depend on what our data model is.
So the implementation of this function will depend on what our data model is. What our data model is.
Whether it's this in-memory list.
Okay. What our data model is. Whether is in-memory base.
SQL, MongoDB, this model function will depend on what our data model is. Whether it's this in-memory list.
Okay, whether it's in-memory list.
SQL, MongoDB, another API, or
exactly. SQL, MongoDB, or relational document base, graph, white color, key value, for example, Redis,
or something else.
Mm-hmm. Relational, DB, document base, relational, document base, graph, key value, pair, or white column database, right?
With our list, we know we already have this products.filter function that will return the products that pass this predicate, this function here, which takes a single value from our list, so a single product. And in our case, we're filtering those products, so we return true when the product.
So here is just to define is this operation we're going to return is the products, since here the implementation will depend on what that data model, what our data model is, whether it's in memory, less, or any other way to persist our state in our app. Meaning, a database, relational graphs, that document base, key value pair, white column. In our case, it's in memory, so we filter, and here we're going to pass is a predicate. What you get is the product, a single product, where here, by defining is a block section, you're going to return is this once the product dot price is greater or equal, if you want to match the price with the minimum value, and the product, it has to be minimum and the product price is the less or equal to the max price.
Price is greater than the minimum, and the product price is less than the maximum. if we wanted to include the minimum and max a price just like that. To use this function,
exactly, we're already returned that.
we need to add it to our exports. And then
Now to use this, it's important here. Now to use this, that's right. Now to use this, we need to export that function, which in our case is here. We will export that as a reference, not as with the parentheses, because we're not invoking that function. So get product by price, and in our product resolver, we're going to import that here by saying the product model dot get product, is in plural. I want to make it clear that it's in plural. Get products by price, by passing is the argument min and the argument max for that. And you want is to assign that to a product like this. You get products by price, and export or return the products by price. So here, if we restart our server here, it shows there's some error with the token, exactly, because this is an arrow function. That's right. So there's another issue here. Not able to get products by price. Get products by price. It's not defined in the product model. The product model, because is here. Okay, and there we go. So now when I don't know how to make GraphQL queries here with parameterized object, or with parameterized
max as the maximum. Now notice that we're not using the parent argument in our resolver. The GraphQL convention, when you're not using one of the earlier arguments, is to name that argument using an underscore.
There's another thing that I look at that. The parameters here. To make this argument an underscore if you're not using it. However, here and import it on our proper resolver, which is here, right? The good practice, or a convention, a GraphQL convention convention a GraphQL convention from exactly. So a GraphQL convention from our product Okay, so a GraphQL convention when you don't need a parameter from a resolver is to use the underscore. Yeah, is to use the underscore.
If there were two arguments not being used, you would use two underscores for the second argument, and so on. There we go. As an exercise, see if you can implement a product by ID resolver and a corresponding product query in the schema. Oh, and before you go, we should name our arguments in the schema the same as Macro product, the reg.
So here, now to make this query, okay, I already know how to implement a query, but not how to perform a parameterized query, which in our case is the way they do that is by product by price. Okay, product by price. Okay, where you're going to pass is the minimum and the maximum. Oh, this is the way how you pass this. Expect name found in integer. Min 10 and max 50. It says cannot find product by price, query, product by price, okay, product by price. So I need to restart this server for that, okay, and then we got it. So once I perform this query, I get is only red shoe for that. Because after all, if we look at the mock data here in our products, we only have is one item here. So if we include this the range to, let's say, 70, we will get these two products here, and it works. Interesting. So with that, I'm going to wrap up this video by today, and well, take care. Bye bye.